Before a single astronaut sets foot on Mars, an AI will have already decided where to dig for water. And the weird part? Nobody's really talking about what happens when it finds too many good spots.
So, okay, let me back up for people who maybe haven't been following the Mars mission pipeline closely. There's this whole field called autonomous site selection, and it's been quietly developing for like a decade now.
Right, and the short version is we have rovers, we have orbiters, we have 10 plus years of surface photographs, spectrometer data, thermal imaging.
An enormous amount of data.
Enormous. And humans have been doing the analysis. Scientists sitting down, looking at images, arguing over where to send the next rover. But we're approaching a scale problem.
Because Mars 2040, or whatever we're calling the crewed mission window, that's a different animal entirely. Completely different. You're not just choosing where to drive a robot, you're choosing where humans live, where they dig for ice, where they try to survive. And the stakes of getting that wrong are, they're not recoverable, right? You can't just pivot.
You cannot just pivot. So that's where the AI comes in.
Okay, so here's what's actually happening under the hood. Because I think people imagine this is like a robot looking at a photo and going, that spot looks good.
Which, kind of?
Kind of, but it's so much more structured than that. What these systems are doing, they're trained on labeled data sets. Orbital imagery cross-referenced with ground truth from Curiosity, Perseverance, the whole lineage of surface missions.
So the AI has seen what a good drill site actually looks like at ground level, and it's learned to recognize the signatures from above.
Exactly. Hydrated minerals, certain clay signatures, subsurface radar returns that suggest ice. It's correlating all of that simultaneously.
Wait, so it's not just looking at one data type?
No, it's more like a fusion problem than a vision problem. You've got spectral data, topographic data, radar, thermal. It's weighting all of these against each other.
Okay, so here's the thing that genuinely surprised me when I went down this rabbit hole, the counterintuitive part.
Yeah, tell me.
The problem isn't that the AI can't find good sites, it's that it finds too many. Like, the constraint we expected was scarcity. We thought we'd be hunting for viable locations. But when you let a system process the full data set,
It comes back with hundreds of candidate sites.
hundreds, and they're all technically valid. So now you have a prioritization problem that humans have to solve. And humans are bad at comparing 200 equally compelling options.
That's such a weird inversion of the expected problem.
Right? We built a tool to find the needle in the haystack, and it was like, here are 900 needles. Good luck.
So how do mission planners actually handle that?
So what happens is, well, first you have to understand that good drill site isn't one variable. It's like habitability potential, resource accessibility, operational safety, scientific novelty.
And those don't always point at the same location.
Never. They almost never do. So you end up running multi-objective optimization on top of the AI output, which is its own whole layer of complexity.
Looping back to what you said about nobody talking about this, I think that's because the conversation is still stuck on, can AI do this? And the answer is yes, it demonstrably can. But the real question is,
Who decides how to weight the objectives?
who decides? Because if you weight habitability highest, you go one place. If you weight resource extraction highest,
Completely different crater, different geology, different risk profile.
and that weighting decision, that's a values decision. That's a human decision. But it gets buried inside a parameter file that most people will never see.
And that's the part that kind of keeps me up at night, honestly. Okay, and I want to be clear that I don't think this is doom and gloom. I think the bigger picture here is actually fascinating.
Yeah, I agree.
Because what we're watching is the first time in history that a non human system is going to have genuine, consequential input into where humanity puts down roots on another world.
That's not a small thing.
That is not a small thing. And the researchers working on this are aware of it. There's real work happening on explainability, making the AI show its reasoning, not just its answer.
Which is genuinely hard. Like, technically hard.
Super hard, but necessary. Because if the drill goes in and finds nothing, someone has to be able to say why the system chose that spot.
Accountability for the algorithm.
accountability for the algorithm, which is a sentence I would not have expected to be relevant to Mars colonization, but here we are. Here we are. Yeah, this one really got me. I'm going to be thinking about the 900 needles thing for a while. Same. I'm Nova. And I'm Alex. And this is Code and Cosmos.